All right, so last section of the unit, yet another application for our matrices. These are called transition matrices, where we can use them to make some predictions within like a business market scenario, okay? So example 1, got a little word problem here. Read it with me. Through a market analysis, a company finds that of all people who buy highlight shampoo, 1 month, 90% will buy it again the next month, 5% will change to Silky Shine the next month, and then 5% will change to another brand. So notice right there in that description, you got 90%, 5%, 5% together. That makes 100%, right? Of those people who buy the Silky Shine 1 month, 10% are changing to highlight next month, 70 will stay with the Silky Shine, and 20 will change to another brand. And then of the users of the other brands, 20% will change to highlight, 20% will change to Silky. All right, so we want to write this information as a transition matrix and label our rows and columns. Okay, so this is going to be a 3 by 3. Okay, and your rows are going to represent from the first month. We can put these in whatever order we want, but I'm going to make the first row for highlight shampoo, so I'll use an H there. Second row, Silky Shine, S, and then the third row, I'll just use an O for other. Okay, our columns are going to be representing to the next month, and we'll use H, S, and O as well. Okay, so it says for highlight shampoo, 90% are going to buy it again. So you started with highlight shampoo, the next month you're going to stay with highlight shampoo. So we're going to put a 0.9 right there. 5% are going to change from highlight to Silky Shine, so 0.05 there. And then another 5% are going to switch to some other brand. Okay. All right. For Silky Shine, let's see, 10% are going to change to highlight. So you're going from Silky Shine to highlight, 0.1. 70% are going to stay with their Silky Shine, so 0.7 there. And 20% changing to another brand, 0.2. Okay. Of the other brands being used, 20% are going to change to highlight. So you go from other to highlight, 0.2. 20% are going to change to Silky. So that's another 0.2. And how many then, what percentage is going to stay with their other brand? 60%, right? Okay, so that is our transition matrix. We'll just call that matrix T. Okay, always set it up that the rows represent the previous month and the columns represent the next month, or whatever the unit of time is you're working with. Okay, click to example 2. Okay, so now we take a market survey and it indicates that the current market shares are 40% for highlight users, 30% for Silky Shine, and 30% for the other brand. So again, add all those up together, that makes 100%. We want to write that current market share as a matrix, and we're going to represent it with the notation M0, M sub 0. Now, there would be 2 ways you could represent this. You could do a 3 by 1, or you could do a 1 by 3. So you could make it look like this, 0.4, 0.3, 0.3, where this is H, S, and O. Or you could make it into a 3 by 1, or I'm sorry, a 1 by 3, 0.4, 0.3, 0.3, where your columns are now H, S, and O. Okay, well, which one do we use? We're going to end up needing the 1 by 3 for the matrix multiplication that we're about to do to work out as we need it. Okay, so I want to find the market share for 1 month later and then 2 months later. So M sub 0 is the current market share. If I want what's the market share going to be after 1 month, I'll designate that M sub 1. And I would find that by taking the current market share, M sub 0, and multiplying it by our transition matrix. Okay? So we'll go 0.4, 0.3, 0.3, H, S, and O. That's going to get multiplied by, let's come back here. I'm just going to copy this. Right there. Okay, so think this is a 1 by 3 being multiplied by a 3 by 3. That means the result is going to be a 1 by 3, right? And we can work this out. So we would take first row with first column. Okay, so notice why we had to set things up the way we did. We're taking the highlight percentage of 0.4 from the first matrix, and it's going to get multiplied by the highlight percentage of 0.9 for the second. Okay, then 0.3 is going to get multiplied by 0.1. Those are the S values. Then 0.3 for O is going to get multiplied by 0.2 for O. So we're just making sure we're keeping all of the brands, together. Okay. All right, so if we actually multiply that out, 0.4 times 0.9, that's going to be 0.36. Added with 0.3 times 0.1 would be 0.03. 0.3 times 0.2 is another 0.06. Okay, and I'll simplify that. It's going to give me 0.45 for the first element of the resulting matrix. Okay, now go first row with second column. Okay, so 0.4 times 0.05, that's going to be 0.02. 0.3 times 0.7 would be 0.21. 0.3 times 0.2 would be 0.06. Adding those up, 0.29. Okay, and then go first row with third column. You get another 0.02 plus 0.06 plus 0.18. And that's going to add up to 0.26. All right, so that is the market share after 1 month. Notice highlight improved. They went from 40% to 45% based on the transition matrix that we utilized. Okay, now what about 2 months later? So we'll represent that with M sub 2, and that's just going to be M1 times the original transition matrix T. Okay, so now we'll take this 0.45, 0.29, 0.26, H, S, and O, and that's getting multiplied. I'll paste this in again by that matrix, and it's going to give me yet another 1 by 3 matrix. Okay, now the calculations are a little more difficult on that one. I did them ahead of time using my calculator. I got a 0.486, 0.2775, 0.2365. All right, so once again, notice that the highlight shampoo increased its market share value, right? It went from, at the start, at the beginning, 40%, after 1 month, 45%, and now we're at almost 49% after 2 months. Okay, so the competitors for Silky Shine and the other brands, right, if the trend continues, they're going to keep losing value of the market, so they got to step it up, right? What do they got to do? Advertise, put some sales on, I don't know, do some coupons, something like that. Otherwise, they're going to keep losing shares. All right, example 3. Okay, so what if M30 is given by the 1 by 3 there, 0.593, 0.222, 0.185, and M31 is the same matrix? What can you conclude about the market share for month 32, month 50? Okay, well, think, if I take M30 and I'm multiplying that by the original translation matrix, or transition matrix, okay, that should give me M31, right? And M31 turns out to be the same matrix. Okay? Well, then I take M31, I multiply that by the same transition matrix. That's going to give me the same result, which we know is supposed to represent, though, M32, right? So if we're going to keep getting the same result repeatedly, by the time we get to the 50th month, still the same thing. We're still going to have the same resulting matrix. So that M30, we have a special name for it. We call it the steady state matrix. Okay? And a steady state matrix S for a transition matrix has the property that when you take that steady state matrix S and you multiply it by the transition matrix, you get itself. Okay? So the values are remaining the same at that point. Okay? And what we're noticing, if you look at the values for M30, 0.593, 0.222, 0.185, highlight is supposed to be represented by that first number, right? They've got the market cornered. They have over 50%, almost 60% of the market at this point. And it's going to continue, they're going to continue to hold that much of the market unless their competitors change their strategy up and do something to shake the market up, right? Okay, final example. Mac and cheese. Who doesn't love mac and cheese? 75% of people who buy Kraft mac and cheese will buy it again next month. 25% will switch to another brand, though. 55% of the people who buy other brands will switch to Kraft next month, while the other 45 are staying with the other brand. Okay, so we're going to come up with a transition matrix for that. Okay, we'll call it T. So remember, rows represent from, columns represent to. I'm going to use K for Kraft, O for other brand. Okay, so 75% who started with Kraft are going to stay with Kraft. 25% are going to switch to the other brand. Okay, and if you started with another brand, 55% are going to go to Kraft, and the other 45% are going to stay. Okay, so now we want to come up with the steady state matrix for this situation. Okay. Well, it's going to have one row and two columns. Okay, one row and two columns, since we're working with a transition matrix that's a 2 by 2. Notice if we go back here, we were working, our transition matrix was a 3 by 3, and our matrices for M were all 1 by 3 matrices, right? So now we need a 1 by 2 for the steady state, all right? So we have that property that S times T is supposed to equal S, right? Well, the steady state is going to have to be X for the first element, and then the second element would have to be whatever X is subtracted by 1, because together they're supposed to add up to 1, right? And you're going to multiply that by T. And we know that this product should result in itself. It should result in that steady state matrix. Okay? So we got a 2 by 1, or I'm sorry, a 1 by 2 times a 2 by 2. That's going to create a 1 by 2. It would be 0.75x plus 0.55 times 1 minus x would be the first element. Second element would be 0.25x plus 0.45 times 1 minus x. And that should equal x 1 minus x. Now we're running short on time, but if you set that element equal to that, this element equal to that, you can solve for x, and either way, x should solve out to being 0.6875. You can check my math later. So 1 minus x then would be 0.3125. So your steady state matrix S would be the following. That matrix, if you multiply it by matrix T, going to get the same result.